Alright friends, here's a video for Tuesday, January 23rd. If you were absent this day or if you just didn't quite follow what was going on in class, this will be a helpful video for you. I'm going to try to keep it quick. If I am going too fast, just pause the video. Alright, so I'll give you time to work on stuff and then I'll say pause the video now, work through these problems. And actually, right on that note, why don't we start with one of those practice sessions. Pause the video here and try to work through A through H. Try to make it all the way through. I've given you the name of the ionic compound here. Use your periodic table to figure out what the formula of these ionic compounds is. All right, so I'll show you the first one. If you got stuck and you didn't know how to do it, I'll show you the first one and then I'll give you another chance to pause and try the rest of them. So the first step here, when I give you the name, you got to find those elements on the periodic table. So sodium is Na, it's over on the left side, it's an alkali metal. Phosphide is the shortened version of phosphorus, which is over on the right side underneath nitrogen. And we know, because we've labeled this on our periodic table, that the sodium ions, so that's sodium anytime it's in an ionic compound, takes on a charge of +1, and phosphorus, or phosphide, always has a charge of -3. So then I can use that and the knowledge that my total charge in an ionic compound always has to add up to 0. I can use that to figure out that I must have 3 sodium ions to cancel out the -3 charge on my 1 phosphide ion, right? If you're having trouble seeing that, look, check it out. I can write another Na and another Na. And now you can see that 1 plus 1 plus 1 equals 3, +3. +3 minus 3 equals 0. And we always know that our ionic compounds, our charges have to add up to 0, otherwise we haven't done it right? So we know it's going to be Na3P. So with that, go ahead and try the rest if you didn't before. And then here's the answers here. So this is BAS for barium sulfide. Magnesium nitride is Mg2N, oh, that's not right, Mg3N2, excuse me. Mg3N2. Lithium, we need 2 lithium ions to cancel out the -2 charge from our oxide. Aluminum and nitride have the same charge, just flip-flop signs. So aluminum's got a +3, nitride's got a -3, so we just need 1 of each there. And we need 3 chlorines to cancel out the +3 charge from our aluminum. And then you probably got stuck for G and H, especially if you were absent on this day. For zinc and silver, we have not labeled those on our periodic tables yet. So if you found zinc and you found silver, you notice that they were transition metals, and we didn't label any charges of transition metals on our periodic table yet. But go ahead and get that out if it's not out. It really should be out. And we're going to label these 2 transition metals as silver having a +1 charge and zinc having a +2 charge. The rest of the transition metals, I'm not going to, well, the rest of the transition metals we will work with, but they're a little bit more complicated. I'll explain more in a minute. But for now, know that silver always has a +1 charge and zinc always has a +2 charge. And the reason for that is kind of complex, and it's above our pay grade, honestly, in 10th grade chemistry. It has to do with the way that the electrons exist around the nucleus in transition metals. They're structured a little bit differently than the rest of the atoms, but we don't really need to get into that right now. So we should have the alkaline metals, alkaline earth metals. We should have boron's column here, nitrogens, oxygens, and fluorines columns, all labeled with their charges, and then also silver and zinc. Not their columns, just them themselves. And with that, now we can see, well, go ahead and give it a shot if you haven't yet, what the formula is for zinc oxide and for silver oxide. And yes, it is ZNO and Ag2O. Because we have a charge of +1 on our silver and a charge of -2 on our oxide, then we need 2 silvers. We need an additional silver to balance out the negative 2 charge for my oxide. So this is going to be Ag2O. And for zinc oxide, well, that -2 and the +2 already cancel each other out, so there's no need to add additional ions, either positive or negative. So we can just leave it ZnO. And there's our little warm-up that we did in class. All right, so that's zinc and silver and the rest of them that we learned yesterday. But there are some, or really all of the rest of the transition metals are a little bit weirder. So to illustrate that point, I want you to go ahead and try to write the name of these compounds in your notebook. Write the formula like I have it here, and then try to write the name and see what happens. So you might have been tempted to go back to your covalent days and call this iron monoxide and iron dioxide, but that's not the case. We don't use those prefixes in ionic compounds. We just use them in covalent. So in ionic, we need some other way to differentiate between the two compounds here, because these are clearly two different compounds. Yeah, they're made of different number of atoms or different number of ions. And so it's like reasonable to assume that FeO probably has different properties than FeO2. They probably have different densities, different melting points. So we can't call them the same thing. They need different names. And the way that we decide what that name is based on the charge of this iron ion. So let's try to figure out what the charge on that ion is. Well, if we look at FeO, I don't know what the charge of iron is right off the bat because I haven't labeled that on my periodic table yet. But I do know that oxide has a -2, right? Oxide always has a -2. And I also know that these have to add up to 0. So then if O has a -2 and we're adding up to 0, that means this iron must have a +2, right? So +2, -2, that adds up to 0. So iron must have a +2 charge. And the way that we name this is going to be, it's a little bit weird, but it is iron 2 oxide is how you read it, iron 2 oxide. But this 2 is in parentheses, and it's also in Roman numerals. And that's for reasons. We couldn't use numbers because, well, I say we. Chemists don't use numbers there because the numbers would signify something else in a different branch of chemistry. So this is the only place, as far as I know, that Roman numerals are used in chemistry, and that is to name ionic compounds. And just one more time, that 2 tells us the charge on that iron ion. So this 2 means that this iron has a +2 charge. All right, so then see if you can figure out what the charge on this on this iron ion. So here we go. The oxide, once again, has a -2 charge, but this time we have 2 of them, right? So we got one -2 charge and then another -2 charge. Those add up to -4. Now, once again, I know that my negative charge and my positive charge have to add up to 0, right? So then it becomes a question of what must this number be? What is the charge of my iron ion? And we should see that it is +4, because then my +4 cancels out the -4 charge of my 2 oxides together, right? So then the name of this compound would be iron 4 oxide rather than iron 2 oxide. And 4 in Roman numerals, if you don't know, is IV. You will have to know Roman numerals up to 6, but not higher than that, because we don't really get ions with great big charges like that. Pretty much stops at 6, at least in this class. So that is our iron oxides. But all of the transition metals, or most of them, can take on multiple charges. So that's unique about transition metals. Like this iron, sometimes it has a +2 charge, but here it has a +4 charge, right? So I don't think it would be appropriate to go to our periodic table and label here +4, but maybe +2, because actually, iron can take on a +1, and it can also take on a +3. So I don't want us to crowd our periodic table, because we would be writing that we'd have so many numbers. here in the transition metals, because all of them pretty much can take on 2 or 3 or even 4 different charges depending on what they're bonding with. So let's just know that all of the transition metals except for silver and zinc can take on multiple charges. And let's actually write that down in our notebook. I hope you're doing this in your notebook, by the way. Let's write down a note to ourselves that all transition metals, of course, except for silver and zinc, can take multiple charges. So that means, right, when they're bonding with other ions or other atoms, they will give different numbers of electrons away depending on their mood, basically, depending on the way that they sort of come together, the conditions under which they bond. We can have an iron giving away 2 electrons or giving away 4 electrons, just depending on the circumstances. And we don't need to know those circumstances for this class. I also want you to write down in your notebook that ionic compounds containing transition metals must have Roman numerals, and I put them in parentheses because they're going to be in parentheses when you write them. Ionic compounds containing transition metals must have Roman numerals in their names. All right. So then, knowing that, if I gave you these 2 formulas, CuCl2 and NiCl, what do you think these would be named? Pause the video here and try to work it out. You're going to have to look at your periodic table. All right, so right off the bat, we know that these are going to have transition metals, are going to have Roman numerals because they both contain transition metals. Copper and nickel are both in that middle section of the periodic table. And then our next step, and we know this is going to be some kind of copper chloride, right? Not dichloride, because we don't need prefixes. But we just need to figure out what the Roman numeral is. And remember that the Roman numeral signifies the charge on one of the metal ions. So it's going to be the charge on our 1 copper ion here. And in order to figure that out, we're going to look at the one that we do know, because we do know the charge of chloride. Each chloride has a charge of -2. That's not right. -1, I'm sorry. And then, so that means both of our chlorides together, our -1 and our second -1, are going to add up to -2. Right? So our chlorides here have a charge of -2. I know that my 2 charges, right, my positive charge and my negative charge, have to add up to 0. So then my copper can only be +2. So that copper must have a positive 2 charge if it's adding up to 0 with the 2 chlorides. So then there's going to be copper 2 chloride. If you missed that one, try to correct NiCl before I show you the answer here. Okay, so once again, we know that this is going to be some kind of nickel chloride. We just need to figure out what the charge is on my nickel, and that goes in the Roman numerals down there, right? So this one's a little bit easier because this time I only have 1 chloride, so my total negative charge is just -1. If my charge has to add up to 0, my nickel must have a +1, so this is going to be nickel 1 chloride. Some people ask, do I have to put the Roman numerals if it's a 1? Yes, you do. You have to specify that it's nickel 1 chloride. I think some people were asking today why it can't just be iron monoxide and iron dioxide. And that's because if we, it actually does matter what the charge on the cation is. Sorry, I call this the cation. The cation is just the positive ion in the ionic compound. It matters what that cation is, what the charge of it is, because if I wanted to take my iron oxide and go do other chemistry with it, Well, if I put it in another scenario, let's say I try to, like, I don't know, dissolve it, then my iron would break apart from my oxides, and my iron would still have that +2 charge, and my oxide would still have its -2 charge. And then those oxygens would go away, but my iron would still have this +2 charge, and it's going to do different chemistry depending on whether it's Fe2 plus or Fe4 plus or Fe1 plus. So it does matter if I'm looking at the compound and I want to do chemistry with the compound. It matters what that charge is, and that's why the emphasis is put there. That's how the identity, or that's how we identify the compound, is by the charge of the cation. And that's just that's just how it is. So much of chemistry is just, well, that's how they decided to do it, and so we just got to keep doing it that way because we're all speaking the same language when we do chemistry. Sorry, I'm rambling now. Can we try a Cu2O and Vn2? Pause the video and give it a shot. All right, so Cu2O. I know right off the bat there's going to be some kind of copper oxide, but I got to figure out what the charge is on my copper, right? You can always start there. You can write the transition metal that it is, and you can write the anion, that's its name. Sorry, that's the negative ion. You can write its name, oxide. And then we just got to figure out what the charge is. So this time, my oxide has a -2 charge. I only got one of them, so my total negative charge in this ionic compound is -2. But I know that this has to add up to 0. Now, it might have been really tempting to say that my copper has a +2 charge, right? But remember, we got 2 of them here, right? So each copper ion must have a +1 charge because they have to add up to +2. You see, and we got 2 of them. So each one's got a +1. So this is copper 1 oxide. Remember, this Roman numeral tells us the charge on one of the ions, not both of them together, the charge on one of the metal ions, right? So my copper ion has a charge of +1. And then this last one here, if you didn't know your Roman numerals, you might have gotten stuck, but this is vanadium nitride. Vanadium is a transition metal. It's over in the middle, a bit towards the left of the middle. And then for our nitride, we know that nitride, based on its position in the periodic table, has a charge of -3. But this time I have 2 of them, so that adds up to a total negative charge of -6. And if that's going to add up to 0, then yeah, we do need a +6 charge on that vanadium. Yes, vanadium can lose 6 electrons to get a +6 charge. It's one of the highest charged ones that I know of. And so vanadium, it'll be vanadium 6 nitride, and that's how we write Roman numeral 6. All right, let's see. Can you give these a shot? So now I gave you the chemical formula, and you go ahead and write the name, and then I'll flash the answers up, and I think we'll move on. If you have any specific questions about any of these, ask me the next time you see me, or shoot me an email if you know you're going to be out for a while. This is iron 1 oxide. This is copper 2 nitride. And this one is just silver nitride. Silver, we don't have to specify that it's silver 1 nitride because silver always has the same one. Remember, we labeled that one on our periodic table. We've seen iron take on now 3 different charges. We've seen it take on a +1, a +2, and a +4. But silver is always the same. It's always 1, so there's no need to specify. And then last thing, go ahead and try these. Same deal. I'm just going to run through the answers real quick. If you can't figure out why one of my right answers is right, or if you are just having trouble generating the answers on your own, again, make a note. Ask me the next time you see me, or shoot me an email if you know you're going to be out for a while. Here's the answers, guys. This is nickel 1 oxide. This is titanium 1 chloride. This is copper 2 fluoride. This one is just zinc nitride. I don't need to specify the charge because it's zinc. Same deal here. This is just calcium oxide. I don't need to say calcium 2 oxide because it's not a transition metal. This one's going to be manganese 3 phosphide. Okay, there's those. Going from the name to the formula now. If you didn't try those, try them now. This is CuO. This is SC2S. And guys, the capitals do matter here. So make sure that you're not capitalizing that C, because then it would be totally different. It would be sulfur and carbon instead of scandium. And nickel 3 chloride is going to be NiCl3, just like that. All right, so we can see that this does take practice. If you expect to get it on the first try, it probably, and then like you just like don't do the practice because you're like, this is easy. You will forget. So do this practice. Don't be lazy about it. And I will have more practice for you the next time that you see me. And then you got to keep up with the practice because it's going to keep building. And you got to really solidify the learning that we do that day before we move on to the next day. So I'm going to be relying on you guys to actually do the practice and ask questions when you get stuck, all right? Or this won't go so hot, and I need this to go well. We all need this to go well. So there's that video. I tried to keep it short. And yeah, I think we're good. Thanks for watching.